To start off, we're going to review the definitions of points, lines, and planes. If you want to stop here and make sure you have these notes or to copy them down, I suggest you go ahead and pause. I'll go ahead and flip to the next page as well so you can see the other definitions. Now, to go back, you need to make sure that you're labeling things in the correct way. Make sure you understand using 2 points when naming those lines. Okay, so those right there. Also remember the correct symbols, like for line segment, for array, and for a plane you just use 3 points or that uppercase cursive letter. For collinear and coplanar, remember what those mean. Points that lie on the same line, points that lie on the same plane. Be sure you know how to list points with commas in between. And then here's an example of each of those from this picture. And that's where we're going to start for 1 through 10, basically. So we have all of these things that we need to name from this picture. So from the picture, we're going to start out with a point. We actually have lots of points. Okay, so we have a point here, 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 and here. Remember, all of those are capital letters, but remember those uppercase cursive letters do not represent points. So M and N here are not points. So if I'm going to list just a point, I know that I'm going to need just one of those capital letters. So for example, point A. Okay, next. I notice I need a line, so remember a line, it extends infinitely in both directions. So notice I have this line here. So I'm going to label that. I can use any 2 points, so I'm going to use points E and C. I could have named it CE. I could have named it DE. I could have used any 2 points as long as I use the correct symbol there. Now, pieces of segments make up the line segment, so I have this piece here that I could name. I have this piece here that I can name. Notice I also have pieces over here. I'm going to name that green one AD. So A, D, and then we have the symbol above it. That's an A. Sorry. Now, array, remember, starts at 1 point and goes in one direction. So I'll start with the end point and then label another point on the ray. So this ray would be D, E, and then I have that symbol. Opposite rays begin at the same point but go in exact opposite directions. So notice those 2 rays both start at D. So DE is one of those. Or DC. So those 2 are opposite rays from one another. Now we also have to name a plane. And remember, we name a plane by either 3 points on that plane or the capital cursive letter. So I have these capital cursive letters there, so I'm going to use that. So that's going to be plane M. Or to name that plane differently with the points, I could have plane F, D, B. Those 3 points are on plane M. So F, D, B. Okay. 2 collinear points. Remember, collinear means on the same line. So actually D and B are collinear. They're on the same line segment. So I could say D and B. And I put a comma between them because I'm listing points here. Another set of collinear points could be A, B, or C and E. Now, 3 non-collinear points. That means that we can't draw a single line between them. So if you take a look, just a second, I need to erase some of this. If you take a look here, I have point E, point B, and point D here, and there's not a single line that I can draw through all 3 at the same time. So we would say those 3 points E, D, and B would be non-collinear. Okay. Now, number 9 is 3 coplanar points. If you notice, those points are actually all on plane N, so those points are actually coplanar. Because they're on the same surface. Now, 4 non-coplanar points. Well, I could use E, D, and B again, but then to make them non-coplanar, I need to add a point that's not on plane N. So the point F is on plane M instead. So those 4 points would be non-coplanar. Okay, moving on here. Now we're talking about intersections. Remember, 2 planes or 2 surfaces will intersect at a line. So we have plane X and plane Y. And so here's this plane and here's this plane. Let me actually highlight those so it'll be easier to see. Okay, so you can see that plane here, this plane here. And what actually happens is we have this line where they intersect. So this whole line is where they cross. So we would say that that is line LM, and that's my intersection of the 2 planes. 2 planes will always intersect at a line. Now number 7, we have the intersection of 2 lines. So here, I need to erase a little here. Now I want the intersection of lines OP and LN. Remember, 2 lines intersect at a point. The point where these are going to intersect is point N. Next thing I have is a ray opposite ML. Okay, so we have the ray from M to L. One opposite with it would start at M and then go towards a point in the opposite direction. Well, in the opposite direction is point N. So that's going to be my ray, MN, with that ray symbol. Make sure you're using the correct symbols when naming those figures. Okay, next we're going to be looking at some segment addition. Just need one line, so I delete the other one. And move this one. There we go. Now, drawing the pictures are going to be the best thing for you on here. If you can't visualize and draw the pictures, then it just becomes that much more difficult to understand the concepts. So we have a segment that has points L, N, and M, and it says L is between N and M. So I have N, and I have M, and then I have L between them. And then we have these expressions that represent the lengths. So remember, when you don't see the symbol above it like this, that means how far those are apart. They just happen to be represented by algebraic expressions here. So we have NL is 6x minus 5. LM is 2x plus 3. And NM is 3x plus 13. Now remember, the segment addition postulate says we have one part plus the other part equals the whole. Well, these two are the pieces, because this is only this part, this is only this part. So those are what's going to go in for both of those p's. Then the whole segment in M is represented by the 3x plus 13. So that's going to go where the W is. So I'm going to erase this, hold on, so I can write down my equation. So I'm going to have 6x minus 5 plus 2x plus 3 equals 3x plus 13. Now I need to solve this. So I'm going to combine like terms on this side. So I have 8x. Negative 5 plus 3 is a negative 2. And that's going to be equal to my 3x plus 13. Now I need to move stuff over. So I'm going to subtract 3x. Subtract 3x. So I'm going to get 5x minus 2 equals positive 13. Now I'm going to add 2. So 5x equals 15. Okay, I'm going to move that over a little bit. 5x equals 15. Divide by 5 and you get x equals 3. Now notice in the problem it didn't ask what x equals. It said find the measure of LM. So now that I know x equals 3, I have to use that to help me find out what LM is. Well, LM was represented by this algebraic expression. So once I know what x is, I just plug that in. So I have 2 times 3 plus 3. Well, 2 times 3 is 6, and 6 plus 3 is 9. So that means that the length of LM is 9 units, and that's my answer. Okay. Next, we have the figure with those lines, and it says segment CX bisects AB at point X. And then it gives us some algebraic expressions. Okay? So we know if X bisects a segment, that means that it cuts that segment in half. So if this bisects this segment, that means that AX will be equal to XB. Okay, we also know, though, that AX is 4y minus 1, and XB is 9y minus 21. Now, what we want to do here is we want to see if we can set up an equation. We can't really use part plus part here because we don't have the whole. But we do know, since this is a bisector here, that these two things are equal. So that's what I'm going to use here for my equation. I'm going to set up 4x minus, I'm sorry, it's not x, for y minus 1 equals 9y minus 21. Now this is an equation I need to solve, so I'm going to subtract 4y. So I have negative 1 equals 5y minus 21. Then I need to add 21. When I add 21, I get 20 equals 5y. Divide by 5, so y equals 4. So we wanted to find the value of x and the measure of the segments indicated, so I need to plug 4 back in. So I have 4 times my 4 that we found minus 1. That's 4 times 4 is 16, minus 1 is 15. I should get the same thing if I plug into the other expression. 9 times 4 minus 21. Well, 9 times 4 is 36. 36 minus 21 is also 15. So you can see by plugging in that we found that they're equal as well. That means that the whole segment, AB, would be 15 plus 15, which would make the whole 30 units. Now, it also asks, what can we say about point X? Well, if we know that the segment CX bisected my segment AB, that means that X was the midpoint. Alright, number 11, if Q is between P and Z, and PQ is 37 and PZ is 75, what is ZQ? So again, draw the picture so we know P and Z is here and Q is between them. And it also tells us some measures here. It says the measure of PQ is 37. So I know from P to Q is 37 units. I also know from P to Z is 75 units. And it asks, what is ZQ? Well, ZQ should be this piece right here. Notice I can use my segment addition postulate that says part plus part equals whole. So I have 37 plus my part equals 75. So I can subtract 37. So I get P equals, let me see, that should be 38. So my answer should be ZQ equals 38 units. All right, number 12. Describe two methods to find the distance between 2 points on the number line. Well, sorry, undo. If we have a number line and we have 2 points on it, what we can do is we can just count. So for example, if I have a point here and a point here, let's say this is at -1, or I'm sorry, -2, and then at +1, I can just count the units to that point. So I could say, well, I could go to -1, then 0, then to +1. So I know my length would be 3. So my first method is really just a counting method. Now, my other method is a little different. What if the numbers aren't so nice? Or we could still use it with the nice numbers actually. Remember, we have the absolute value of the difference. That means taking the absolute value of subtracting the coordinates. So I had the two coordinates here that I was counting between, -2 and +1. So if I have -2 minus 1, well, -2 minus 1 is actually a -3. But remember, distances can never be negative, so that's why we do the absolute value. So we get 3. Could have also gone the other way. I could have said, well, what if I wanted to put the 1 first? So I could have done 1 minus a -2, and that would have given me +3. So notice I get the same length no matter which method I used. Here I had length is 3, here I had length is 3, here I had length is 3. So our two methods are counting and then also absolute value. Well, helps if I can spell. Absolute value of the difference. Okay, number 13. What is the distance between point A at x equals -2, or x equals +2, and point B located at x equals -10? So first thing I need to do is I need to plot those points. So at -10 we have point B, and then at +2 we have point A. Now I'm going to show you both methods with this. So you could just count and you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know our answer has to be 12 units. You could also use our absolute value method, where we use the coordinates. So I have -10 minus 2, and taking the absolute value. And 10 minus, or I'm sorry, negative 10 minus 2 is a negative 12. So then I take the absolute value and I get 12. I could go the other way. I could say, well, what is 2 minus a negative 10? That is positive 12. So notice, by counting or by the absolute value, notice I get the same answer. Now, the next one, again, drawing the picture is going to be your best strategy here. So we have the length of MN is 6.9 units, and M is located at x equals negative 2.3. So I'm going to draw a line here, and it says M is at negative 2.3. Where could point N be located on the number line? Well, we know that N is 6.9 units from M, so I would have to count that many units. But the decimals don't really help us count like we could hopping on the number line here. So instead we have to think about, well, how did I go from B to A? Well, in order to go from negative 10 to positive 2 here, I would have had to add 12, going in that positive direction. So I can do the same thing here. From M, I'm going to move 6.9 units. And then I'm going to land at point N. Well, if I'm moving to the right, that means I'm adding. So that would mean negative 2.3 plus 6.9. So negative 2.3 plus 6.9 would be 4.6. And that would be a possible answer for where N is. But it didn't specify where N was located in reference to M. So I could have actually gone the other way. What if M was still at negative 2.3, but instead of going to the right, I decided to go to the left. So I can still go 6.9 units to the left of M. So when I go to the left on the number line, say going from 2 to negative 10 here, I would have subtracted 12 to get to negative 10. 2 minus 12 would give me that negative 10. So here, if I have negative 2.3, I'm going to subtract 6.9 to get my new coordinate. To get my new coordinate, I have negative 2.3 minus 6.9. So that gives me negative 9.2, I believe. So there's my other answer. So I actually have two solutions to this problem. So point N could be at x equals 4.6, or N could be at x equals negative 9.2. Both of those are possible solutions here. Alright, number 15. So on number 15 we have some decimals here. What I want to do is I want to plot where those would approximately be on the number line. So I would have positive 2.78, so that would be approximately there. So that's point A. Then B is at negative 1.67, so that's approximately here. And I want to find out the distance between them, or the length of the segment. So I want to find out how far they are apart. Now you might notice here that counting is not going to be our best strategy here. We know we can estimate. We know it should be around 1, 2, 3. It should be a little bigger than 3 because we have leftovers on each side, and we counted 3. But it's not exactly 3, so we're going to have to use the coordinates here to come up with our answer. And this is where the absolute value method comes in. So I would have absolute value of 2.78 minus a negative 1.67. So what is 2.78 minus a negative 1.67? So let me see here. That's going to be a 5, carry the 1. That's going to be a 4, carry the 1. And I get 4.45 units. So notice our estimation of 3 was way off. We were off by over a unit there. Okay, you could have also gone the other direction and done negative 1.67 minus 2.78, and you would have gotten the same answer. Okay, number 16 is where we start talking about that fractional distance. Fractional distance just means how much of the line is being represented by a fraction. So if we break it up into thirds or fifths or fourths, we want to know what fraction of the line is being represented. So here we have points that we can plot. So I have my first point at negative 2. Let me see. Okay. My next point, okay, so that was point W. My next point is at positive 5, so we have negative 1, 0, 1, 2, 3, 4, 5. So there would be my Y. And then at 19, I have point Z. So there's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think that is right. Whoop. So sorry, my elbow hit my iPad and opened up one of my apps. So sorry. So I'm off here. So 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, and 19. There we are. So there's my 19, and there's my point Z. Now, I want to know what fractional distance Y to Z represents. So I'm going to have to relate that back to the length somehow. So I'm going to try and find the entire length first. Well, the entire length would run all the way from W to Z. Well, how can you find WZ? Well, what is the distance between negative 2 and positive 19? Well, that distance should be 21 units. Then what's the distance between Y and Z? Well, Y is at 5, Z is at 19. So YZ is 14 units. So I want to know what fraction 14 is out of my total of 21. So put that as a fraction. 14 over 21. Reduce by a factor of 7 and you get 2/3. And that's my fractional distance. This 14 is 2/3 of the way out of my whole 21 units. All right, number 17. I have a point C at -4. So I'm going to start here at -4, point C. And then I need to count all the way to 16. So there's -3, -2, -1, 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. There we go. And that is point J. Now, I want to find point G that is 3/5 of the way from point C. So, just like on the last one where I found my fraction, this time I have the fraction, and I need to find out where that point is in the middle. So, I have this entire segment, and I want to find 3/5 of the way. Well, I've got to have the total first. So my total means I have to count all the way from C to J. That length is 20 units. Now I need to find out how much 3/5 of the way would be. So I need to find out what 3/5 of 20 is. Well, 3/5 of 20, that just means I'm multiplying those two. So if I were to multiply this out, 20 divided by 5 is 4. 4 times 3 is 12. So I know that 3/5 of the way should be 12 units. Now I just need to count, because I want it from point C, so I need to count 12 units from C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that point G should be right here. Now, where is that on the number line? So there, now I'm just going to have to label my numbers here. So that would be -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Another thing you could have recognized here is that numerically, -4 plus 12 gives me 8. Let me write that down. -4 plus 12 equals 8. Notice that's where I ended. Okay, moving on. Now we're looking at conditional statements. So on number 18, we want to write the conditional with this hypothesis and this conclusion. So remember, a conditional is just P implies Q, or if P then Q. So I'll have if Mary gets enough sleep, then Mary does well in school. Now on number 19, we want to write the negation of both of those. The negation, remember, is the opposite. So if my hypothesis is Mary gets enough sleep, the negation of that would be Mary does not get enough sleep. So Mary doesn't get enough sleep. My conclusion is Mary does well in school, so if I'm going to negate that, that's Mary doesn't do well in school. All right, number 20. We're given the statement, all Midlanders are Texans. A Midlander is someone from Midland. Now we want to rewrite that statement as a conditional. Conditional means if and then. So I need to figure out what two things it's talking about here. Well, the first thing it's talking about is being a Midlander. The second thing it's talking about is being a Texan. So I'm going to use those two things to write my conditional. So I'm going to say if you are a Midlander, then you are a Texan. Alright, so what is my hypothesis here? So let me highlight that. So my hypothesis is after if. So you are a Midlander. Then my conclusion would be you're Texan. I'm not going to rewrite them. I'm just going to highlight them. You can rewrite them again down here if you like. The next thing we're going to do is write the converse, inverse, and contrapositive. Remember, the converse is the switch of my original. So instead of P implies Q, we would have Q implies P. My inverse is the negation of the original, so that's not P implies not Q. And my contrapositive is switching and negating, so that is not Q implies not P. Now, my converse is the switch of the original, so let me put a different color here. My original is if you're a Midlander, then you're Texan. So the converse is the switch of that. So if you're Texan, then you're a Midlander. Sorry, that ended up really messy there. Better, okay? Now, inverse is where I am negating my original. So I would say if you are not a Midlander, then you are not Texan. Then the contrapositive is switching and negating. So if you are not Texan, then you are not a Midlander. Alright, so notice the patterns here. P then Q, Q then P, not P implies not Q, and not Q implies not P. Okay, that's it. Make sure to rewind and replay anything that you missed, and I will see you back in class.